Today we're going to learn about the derivative power rule. And we have to find what is d dx of 7x squared using the power rule. So first let's figure out what the power rule is. But before we get to that, let's find the derivative for x squared, x cubed, and x. So let's start with x squared. We have the limit as h approaches 0 of f of a plus h, or f of x plus h, minus f of x over h. So when we use x squared as the function, then we get f prime of x is equal to f prime of x is equal to the limit as h approaches 0 of x plus h squared minus x squared over h, which becomes x plus h squared is the limit as h approaches 0 of x squared, x to the power 2 is x squared, then we have x times h, which is xh, and we have that twice, so it's 2xh, or 2hx, and then we have plus h squared minus x squared, all over h. So now we can see that we have some terms that cancel out. So we have x squared minus x squared, so that cancels out. And then we can see in the remaining two terms that both of them are divisible by h, so we can take out the h from the denominator, take out the h here, and take out the exponent here, because the exponent here is 2. And so h squared divided by h is just h. So this is equal to the limit as h approaches 0 of 2x plus h. So as we can see, because we're not having a denominator that is just 0 when we plug it in, we can use direct substitution. So we substitute 0 in for h, and we get 2x. So the derivative of x squared is 2x. Let's write that here. You can take a moment to look at this. The derivative of x squared is 2x. So let's write that here. F prime of x equals 2x. Now let's move on to x cubed. We have the limit as h approaches 0 of x plus h cubed minus x cubed over h. So let's take a moment and figure out what x plus h cubed is. X plus h cubed is x plus h times, now we have x plus h squared, which is multiplied by x plus h. X plus h squared is, as we saw in the last problem, x squared plus 2xh plus h squared. So that means that x plus h cubed is, now we multiply these together, x times x is x cubed plus 2xh times x is 2x squared h plus xh squared. Now we have to multiply everything by h, so we get h times x squared is hx squared, or x squared h, two xh times h is 2xh squared, and then we have h times h squared, which is h cubed. So this is equal to x cubed plus 2x squared h or plus 3x squared h, sorry, plus 3xh squared plus h cubed. So now let's rewrite this, plugging in this expanded form instead of this. So we get the limit as h approaches 0 of x cubed plus 3x squared h plus 3xh squared plus h cubed minus x cubed all over h. So you can take a moment to look at this. So now, as we can see, we have some terms that cancel out. X cubed minus x cubed cancels out. 3 and all the remaining terms, as we can see, are divisible by h. So let's do that. In this one, the h gets cancelled out with this h. Here, the exponent gets cancelled out because h squared divided by h is h. And here, the exponent becomes 2. So, we're left with the limit as h approaches 0 of 3x squared plus 3xh plus h squared. As we can see, we don't have a denominator that when we plug in h becomes 0, so we can just use direct substitution and plug in 0 for h. This is equal to 3x squared, because we get 3x squared plus 3x times 0 is 0, plus 0 squared is 0. So that means that f prime of x for x cubed is 3x squared. F prime of x is equal to 3x squared. Now let's move on to finding the derivative of x. So we have the limit as h approaches 0 of f of x plus h is just x plus h because the function is just x. So we have the limit of x plus h minus x all over h. So this one's an easy one. We can see immediately that terms cancel out. X minus x cancels out. So we get x minus x cancels out. And then we're left with h over h, which is just 1. So we have the limit as h approaches 0 of 1, which is equal to 1. So that means that the derivative of x is 1. The derivative of x is 1. F prime of x equals 1. So as we can see, there's a correlation between all three derivatives and their functions that is similar. So from x squared, we get 2x. From x cubed, we get 3x squared. And from x, we get 1. Let's try and figure out what the pattern is here. You can take a moment to pause the video to figure out the pattern. Well, the pattern here is that the exponent of the function becomes the coefficient of x, and then the exponent decreases by 1. So, the formula that is written out in the textbook is if f prime of x is equal to x to the nth power, then that means that f prime of x is equal to n times x to the n minus 1 power. This is known as the power rule. So this is known as the power rule. Now let's solve the problem. We have to find d dx of 7x squared. d dx is known as Leibniz notation, which is just another way of writing the derivative. So this just means find the derivative of 7x squared. So we have to find the derivative of 7x squared. Let's write that down. Because one property of limits that we know is that if you have a coefficient and then x squared, then this becomes this coefficient 7 times the limit as h approaches 0 of x squared. This also works with derivatives, because derivatives are just one application of limits. So d dx of 7x squared is equal to 7 times d dx of x squared, which is equal to 7 times the derivative of x squared is we bring the coefficient, or we bring the exponent and make it the coefficient of x, so times 2x, and then the exponent decreases by 1. So the exponent here, in this case, would become 1. And we don't have to write that down because we know x to the first power is x. So this is equal to 7 times 2x, which is equal to 14x. Another way that you could have done it is just multiplying this coefficient by the exponent, which would become 14, and subtracting 1 from the exponent. This is the same thing as a power rule, except we're not splitting off the coefficient here off to one side.